Today we will be making a short educational video demonstrating Newton's 3 laws using real-world examples. Inertia. So the first law is sometimes referred to as the law of inertia, which means a tendency to do nothing or remain unchanged. The tendency of an object to resist changes in its state of motion varies with mass. Mass is that quantity that is solely dependent upon the inertia of an object. The more inertia that an object has, the more mass it has. The first law. This law states that an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. If I have a car that's moving in a straight line on a flat road with a constant velocity of, let's say, 20 meters per second, that car will stay in uniform motion unless force like friction, which is an opposite force, is applied to the car that will help bring the car to a stop. Or deceleration force acting on the object, there is only Fg and Fn, normal force and force of gravity. So let's say if the car is 1300 kilograms, then the force of gravity 9.81 multiplied by the mass will have an Ft of negative 12,750 newtons. The second law. The second law states that the rate of change momentum of an object is directly proportional to the unbalanced force in the direction of force. This gives us an equation for acceleration multiplied by the mass of the object is equal to force. If me and Yoni tried pushing a car and it weighed 1300 kilograms and we moved it at 140 meters per second squared, you can calculate the force that we moved the car, and that would be 182,000 newtons. If we had another car about 1500 kilograms and we moved it at the same distance in the same time, but it weighed more since the mass is more, the applied force would be 210,000 newtons. If applying the same force to two objects with different masses, the object with less mass would have more acceleration due to needing less force to move it in general. If we had another car about 1500 kilograms and we moved it at the same distance in the same time, but it weighed more since the mass is more, the applied force would be 210,000 newtons. If applying the same force to two objects with different masses, the object with less mass would have more acceleration. Third law. This law states that for every action, there's an equal and opposite reaction. Exerting force on an object will exert the same force back onto you. For example, dropping a car onto the ground and it hits the ground with a force of negative 150,000 newtons, the ground will exert an upward force of 150 newtons back until other forces act on it, such as Fg pulling it back to the ground. This brings us back to Newton's second law involving mass, where as the ball would bounce much higher because the mass allows the ball to accelerate more, where the car would need a much higher acceleration to bounce greater than the ball.